Alright, here we go. Page 2, finding limits. Always when you're taking the limit of a function and x is approaching a real number, then we want to just replace x with that real number. We're dealing with a rational function here. As long as we get a real number, then we're good. But what we find out here is when we replace x with 4, we get 0 over 0, which means we really don't know anything yet. We don't even know if we have a limit or if the limit exists. So we see that we can factor the numerator, and when we factor the numerator and cancel the factors x minus 4, then we understand that we have number one, we have a hole in the graph, so the limit does exist. And then when we replace x with 4, with what's left over after we cancel the x minus 4s, we see we get 4 plus 4, and which is just 8. Okay. Now, the next problem off to the right here, that's a problem in which we're really not sure what that graph looks like, so we're going to use our calculator. We're just going to type in the function in our y1, making sure we're in function mode. But going into y1, zoom 6, remember what we're doing is we're replacing x with 0. We're finding the limit of this function as x approaches 0. And so if we go ahead and zoom in, we could zoom in like this, and we could move the cursor up to where it looks like the y-intercept is. And it looks like we have a limit. In fact, we do have a limit. We just have to figure out what that value is. If we second calculate value, when we type in x equals 0, we see that the value just to the left is 2.58, and just to the right is 2. Well, this is not the way that I would actually go about finding a limit. I want to use the table feature on my calculator, so this is just to get an idea of of what's going on right around that value in which x is equal to 0. We could also trace, and if we go just to the left of 0, we see that as x is approaching 0 from the left, we see that we get about 2.167, and then just to the right 2.449. So we're zooming in on something around a little over 2. But anyway, the best way to find the limit is just to start the table at, let's say, negative 0.01, and increase the table by 0.001. And then when you go to the table, you can see the values along the left-hand column are x approaching 0 from the left. And we can see right up here that y is approaching 2.2999, so 2.3. And over here, from the right, as x is approaching 0 from the right, we can see that the y values are approaching 2.3 from the right as well. So we could conclude that 2.3 is the right answer. Now if we dug a little deeper and we set our table at negative 0.0001, and we increased our, sorry, I meant to put negative there, negative 0.0001, and we increased by 0.00001, so you're not ever going to have to go this far, but we can see that as x approaches 0 from the right, we actually get a little bit closer to the y value of 2.303. So 2.303 would be the better of the two, but 2.3 would be just fine in terms of what the limit of that function is as x approaches 0. Okay. The other limits, we don't need our calculator, and so here we are at a little over 4 minutes. Okay, to keep these videos under 5 minutes. As x approaches negative 1 from the right, doesn't matter right or left on this one, it's just a polynomial function. We see we get negative 1 to the third minus 2 times negative 1 squared plus 3. So it's negative 1 minus 2 plus 3, so we just get 0. Okay. And over here, if we replace x with negative 1, it's probably going to be 0 over 0. I'm just going to assume it is. And so I'm going to factor the numerator and then factor the denominator. Cancel the x plus 1s, and we get 4 over negative 5. I've got to stop.